So Jai Hind everyone. This is Shreya and I am back again with a new topic, with a new chapter of IGCSE A level. So let me write down the name of the chapter and then we will move on. So the name of the chapter is Rotational Dynamics. Rotational Dynamics. Okay. This is the chapter number 25 of IGCSE. IGCSE chapter 25. Let me write down chapter 25. Okay. Section 4 A level. So this topic, this chapter we are going to discuss today. In this chapter we have to start with angular displacement. Angular displacement. A small topic. Initially we need to introduce with this topic and then we'll move on. Okay, so let us start. Suppose a particle is moving on a circular path. Suppose a particle is moving on a circular path. Let it be the center of the circular path. Let us join. Let this be the radius of the circular path. Okay, and the particle has moved from this O point to A point. The particle has moved this O point to A point. OB is a straight line. Definitely it is the radius of the circular path. OAB is also be the straight line and it is also be the radius of the circular path. OB is also the radius, AB is also the radius. That we know from our very basic concepts of math. Okay. Now the angle subtended over here, as you can see, the angle subtended over here is denoted by theta. Is denoted by theta. So let me write down it again. This is your theta. Okay, so we have marked it as theta. Now this theta will be termed as angular displacement. This theta will be termed as angular displacement, and OA is the arc. OA is the arc. So one by one, let us write down OA is equals to arc. Okay, OB is equals to AB. OB is equals to AB is equals to radius. OB is equals to AB is equals to radius, and OA is being referred as L. Let's take OA is equals to L. Now from the very basic concepts of math, that theta is equals to arc upon radius. Theta is equals to arc upon radius. The value of arc we have considered is L, and the value of radius we have considered as theta. The value of radius we have considered as theta. So if we consider that the particle was initially at 0 degree, if we consider the particle was initially at 0 degree, from the diagram we can say the particle was initially at O. So the angle theta is being termed as theta 1, is being taken as theta 1. And now the new position of the particle is A. So the final angle of the particle with respect to the horizontal or with respect to point O is O2 or theta 2. So let us mark over here that initially the angle subtended by the particle at O is equals to theta 1 and at A is equals to theta 2. Therefore, theta 2 minus theta 1 can also be termed as delta theta. So delta theta is the small change in value of theta. Delta theta is small change in value of theta. So let me write down delta theta equals to small change in the value of theta. Therefore, we can consider that delta theta is nearly equals to theta, and the value is L upon R. And the value is L upon R. So one more point that we should add, that displacement is basically a vector quantity. Then angular displacement will also be a vector quantity. Displacement is a vector quantity and angular displacement will also be a vector quantity. So delta theta is your angular angular displacement, displacement, and it is a vector quantity. It is a vector quantity. The SI unit is radian. The SI unit is radian. Okay, so this is the all information about the angular displacement. Now when we are moving towards angular velocity from angular displacement, we need to recall about the basic definition of velocity that we have studied in motion in a straight line, when the particle is performing translatory motion or linear motion, we must say. The rate of change of displacement is known as velocity, that we know. From class 9 standard, we have studied this definition, that the rate of change of displacement is known as velocity. For angular velocity, we must say that rate of change of angular displacement is angular velocity. The rate of change of angular displacement is angular velocity. Like we have used, the rate of change of displacement is called velocity. So we have just added the word angular to it. So angular velocity is our next topic. Angular velocity. And the angular velocity is denoted by omega. This symbol is termed as omega. Let me highlight it. This symbol is termed as omega. Okay, so rate of change of angular displacement is called angular velocity. So if I suppose that delta theta tends to 0, delta theta tends to 0, okay, and with respect to time delta t also tends to 0, then the ratio of, we must write down, limit delta t tends to 0, delta theta upon delta t will changes to d theta upon dt, and this d theta upon dt will be termed as omega. Omega is equals to d theta upon dt. This is the formula. Omega is equals to d theta upon dt. So the SI unit is radian per second, and it is a vector quantity, okay. So we got the information about angular displacement and angular velocity. Now from angular velocity we need to move to angular acceleration. So again we need to recall the basic definition of acceleration, that the rate of change of velocity is called acceleration. In the similar way, we are going to add up the word angular to it, and the definition will become the rate of change of angular velocity is called angular acceleration. I am repeating again, the rate of change of angular velocity is called angular acceleration. So like we have studied in linear motion or in translatory motion, that um, acceleration is equals to dv upon dt. In the similar way, in case of rotational motion, the acceleration is termed as angular acceleration and is noted by alpha. Alpha is equals to d omega upon dt. This is the formula that we are going to use. Alpha is equals to d omega upon dt, and again the quantity is a vector quantity. It is a vector quantity. Let me write down. It is a vector quantity and SI unit is radian per second square. This is the SI unit. Okay. So again, we got few formulas. The first formula is of angle theta, or we must say that theta is equals to arc upon radius. First formula. Second formula, omega, rate of change of angular displacement is called angular velocity. The third one, the rate of change of angular velocity is called angular acceleration. Now we just need to look about the other formulas of angular velocity. Okay, some other formulas. Some other formulae. One thing may run in your mind, why we are using the term angular to it. So again, for the word angular, we must say that whenever the particle is revolving on a circular path, then the particle tends to have some angle with respect to the initial position or with respect to the center. That's why the word angle is taken into this consideration. Again, I am repeating, since the particle is uh, moving on a circular path with respect to an initial position or with respect to the center, the particle is extending some angle to it. Hence, the word angular is being considered or being incorporated in the terms, in the parameters, in the physical parameters. Okay, so let us see some other formulae of angular acceleration as well as angular velocity. So the other formula of omega is 2 pi by t. This is one of the other formula of omega. Why 2 pi by t? Again, why 2 pi by t? Because the complete circle, in a complete circle, as you can see in slide number 2, in a complete circle, the particle will be covering 360 degrees, and the 360 degree in radian will be equal to 2 pi. The 360 degree in radian will be equal to 2 pi. Hence, the time taken by the particle to cover this 2 pi distance will be equals to angular velocity, that is omega. So the omega will be equals to 2 pi by t, that I have written in slide number 12. From the basic concepts again, 1 upon t is equals to frequency. So the other formula of omega is 2 pi nu. So now we have got three different formulas of angular velocity. The first one is d theta upon dt, the second one is 2 pi by t, and the third one is 2 pi nu. Let's move on to the next one. Relation between linear velocity and angular velocity. Okay, we need to find the relation between linear velocity, that is denoted by v. Okay, linear velocity denoted by v, angular velocity denoted by omega. Okay, so we need to find a relation between v and omega. So let us write down the value of v. V is equals to L upon t, distance upon time. This is one of the very basic formula of velocity. Velocity is equals to distance upon time or displacement upon time. We know that. So let us mark as equation number 1. Okay. From omega, we know omega is equals to delta theta upon t, or in short theta upon t we can write down. Okay, this theta is your angle. So the formula of angle is L upon R, isn't it? The value of angle is equals to L upon R. Let us mark it as equation number 2. This is your equation number 3, and the previous equation we have already marked equation number 1. Putting equation number 3 in equation number 2, what we will be getting? Omega is equals to L upon R T. So from L by T, if I take this, we can write down V in place of L by T. So omega equals to V upon R is the formula. So let me write down again. Omega is equals to V upon R. This is one of the formula, or we can say omega R is equals to V. For both we can take. We can also go for this formula. We can also go for this formula as per the numericals is being asked. In vector form, since linear velocity is a vector quantity, angular velocity is a vector quantity, and this r radius will be treated as radius vector. This r which is written over here, it is the radius, and this r is the radius vector, will be treated in this respect. So in vector form, v is equals to r cross omega. Okay, with a negative sign. V equals to r cross omega with a negative sign, or if I write down in positive values, V equals to omega cross r. This is the formula in positive. As we know that vector cross product is anti-commutative in nature. As we know that the vector cross product is anti-commutative in nature, hence if we need to write down, then we should write that V is equals to omega cross r, that is the positive value, and V is equals to r cross omega with a minus sign, that shows that we have taken that the anti-commutative aspect of the cross product. We have discussed the anti-commutative aspect of the cross product. Hopefully you have understood this topic. Please go through all these slides for a better understanding, and if you have any queries, then please respond on my link. Thank you.